Hello and welcome. So today we're going to be talking about if statements, and that will include if, elif and else in Python. We will start off by talking about the Boolean operators. So if I make a new text file and show you these. So we have four main Boolean operators used for comparisons in if statements. And they're called Boolean operators because they equate to true or false. So the answer is either going to be true or the answer is going to be false. And of course, yes is for true and no is false in Python. So the first one is two equal signs. And let's make this a bit bigger. So we have two equal signs, and that means is equal to. So if we have two equal signs, it means is equal to. So is whatever is to the left equal to whatever is on the right. So if I do 5 equals 6, the answer is going to be false, or the outcome of this Boolean operator. So 5 is not equal to 6. They are not the same thing. Now, it's important to consider that if you're using this with variables, then if you only have one equal sign, then the variable to the left will become equal to whatever is on the right. So if I put num1 equals 6, it will replace num1 with the value 6, so the value 6 will be stored in num1. If I do two equal signs, it will say is num1, whatever is stored in that variable, is it equal to 6? And they are not the same thing. And that's very important, and we'll talk a bit more about that later on. So the next Boolean operator we'll look at is not equals. So it means not equal to, and I should say means is not equal to. So if I do the same numbers and I do 5 not equal 6, the answer is true. 5 is not equal to 6. And in programming, if you see an exclamation mark, it means not or the reverse of. So not equals is the opposite or the reverse of equal to. So 5 is not equal to 6. The next one is less than, and we always read code from left to right. So 5 less than 6, that is the way round that the symbol should be. So 5 is less than 6, we read from left to right, and this will be true. 5 is less than 6. The last one is greater than. So greater than. And again, we read left to right. So is 5 greater than 6? And the answer is false. So for the four main Boolean operators, we have is equal to, not equal to, less than, and greater than, and we can use these for all of our if statements, and I will show you this now in Python. So let's get rid of this, let's delete that, open Python, move this over a little bit, make a new file, move this over, and I'm going to configure idle to make the text a little bit bigger so that it might be a bit easier to read on the screen. So if I create two variables, num1 and num2, and we give them the values 5 and 6, we can now start using some if statements. So if I say if num1 is equal to num2, then I'm going to print out they are the same. So this is saying if keyword in Python, it comes up in orange. If it doesn't come up in orange, then you've misspelt it, or maybe you've put it with a capital and it shouldn't be a capital, it should be all lowercase. If, and we're taking variable num1, we're using the is equal to operator and then a second variable. You'll notice at the end of every if, elif and else statement in Python you need a colon, and the next line, if you've added a colon, should automatically indent. And this, I believe, is set automatically to 4 spaces. You can, in idle, again going to options, you can change that to be 3 spaces, but it automatically indents to that, which is just, if you press tab, it should indent to the same level. And all I've done then is said print, they are the same. So when I run this, save this first, if statements, you'll notice it doesn't do anything. And it doesn't do anything because that is not true. I could say else, we're going to print they are not the same. And this is saying else, which is basically otherwise. So if num1 is equal to num2, do this, print this, otherwise or else, and then we have the colon, print they are not the same. And you'll notice else is also in orange. And now when I run it, it should say they are not the same. So the whole purpose of the if statement, and an important point, is that this will only do one of these 2 options. It will never do both. If it does both, then something has gone horribly wrong. So we can do this the other way around. We can say if num1 not equals num2, we're going to say they are not the same, else they are the same. So this way is saying as if num1 is not the same as num2, we're going to say they're not the same. And again, when I run this, it now does the top option, they are not the same, which is just this one. It doesn't do the second option. And of course, I can use the other operators. So I can say if num1 is less than num2, I can say num1 is smaller. Otherwise, I will say num1 is larger. And if I run this, it will say num1 is smaller. So num1, which is 5, remember, is less than 2, which is 6. So it will print out num1 is smaller. This else gets ignored. Once it's gone through this block of code, it exits to the next line out here. So if I go print hello, you'll notice it says num1 is smaller and hello. So it does this first option and then skips to hello. I could do the same with the greater than symbol. So num1 is greater than num2. I can change this to larger and smaller. Similar sort of idea. If num1 is larger than num2, we're going to say num1 is larger. Otherwise, it is of course smaller. And if I change these around so that num1 is now 7, it will say num1 is larger, and it will still say hello. So it will do this one, skip the else block, and go to that one. Whereas if it's smaller, it will skip the first block, go to the second one, and then it will print hello again afterwards. Now, an important note, if you try to do num1 equals num2 and you run this, you will get an error. And it says here, invalid syntax. You can't assign a variable to another value inside an if statement. So it's saying you can't use one equal sign, you need 2, and then it will work. And of course, you don't have to compare a variable to another variable. We could compare a variable to a number. So I could say if num1 is equal to 1000, I can say num1 is 1000. And then I can say elif num1 is larger than 500 or greater than 500. Num1 is larger than 500. And then else print num1 is smaller than 500. And if I run this, it will say num1 is smaller than 500, and then it still says hello at the end. So just a quick rundown of this, it's saying if num1, which is 5, so if num1, 5, is equal to 1000, it will say num1 is 1000. elif means otherwise if, so otherwise if num1 is greater than 500, it will say it's larger than 500. Else or otherwise, num is smaller than 500. So seeing as num1 is 5, it's not either of these two, so it only does that. If I do 501, it will say num1 is larger than 500. But note, if I do num1 as 500, it will still say num1 is smaller than 500, which is not quite correct. So I could change this to num1 is greater than or equal to, using the equal sign after the greater than sign. So if num1 is greater than or equal to 500, then we could say num1 is at least 500, because this may mean it's 500 or larger. So a couple of important notes here. We can do less than or equal to, we can do greater than or equal to, but another important note, elif is another key term, key word in Python, and it will again come up in orange, and with if and elif statements you need to have a condition. So this is my condition here, is num1 greater than or equal to 500. For the else statement you don't need a condition. This is meant to catch any other scenario. So if it doesn't meet these two conditions, this will catch everything else, and that doesn't need a condition. Now, we can of course ask the user for some input, so we could do num1 equals input, please enter a number, and this will create a string, and you'll notice straight away that I'm trying to compare a string to an integer, and we'll see what happens. And it will say greater than or equal to not supported between instances of str and int. So it does actually do this one, num1 is equal to 1000. Well, a string can never be equal to an integer, so that will never work out. But it is saying that we can't do this. Interestingly enough, if we actually get rid of this statement, and I'll copy this for later, if we get rid of this and I run it and I enter 5, it will say num1 is smaller than 500, because this will never be true, and it automatically goes to this. And I will prove that even if I type 1000, it will say num1 is smaller than 500, because the string 1000 is not the same as the integer 1000. They are stored differently. So if I do print type num1, you will see it is indeed a string, and we are trying to compare a string to an integer. It will just never work out. So let's put our elif statement back in, and let's add int input, and we can go again, and we can say this time 1000, and it will say num1 is 1000. And we can do the others. We can do 750, num1 is at least 500, etc, etc. Now, another important note, if we put a float and we go enter a number 1000, it will still say num1 is 1000. So it considers the float 1000 the same as 1000 without the 0.0, but it will not consider a string in the same manner. So we can also, if we like, have more elif statements. So we can have elif num1 is greater than or equal to 250, we can print num1 is at least 250, and if I go, let's say 300, it will say num1 is at least 250. So you start with one if statement, you can then have as many elif statements as you like, and then you end normally with an else statement. Sometimes if you only want a message to be printed in the case that it is true, you could just do if with no else, and this way if the answer is 1000, it will say num1 is 1000. If we run it without the number being 1000, it won't do anything, it will skip on to the next line, which just says hello. So in some instances we don't actually want something to happen if this isn't true. It might be that if num1 is 1000, we're setting a variable to be true that we're going to use later on, or we want to replace it with another value, something like that. The last thing I want to show you is to do with the Boolean value from last time. So when I said you shouldn't really ask the user for a Boolean value and convert it into a Boolean because of the way that works, what we can do is we could say something like heads, for heads or tails, equals input, enter heads or tails, and then we could say if heads is equal to the string heads, and note that this has got the quotation marks around it, so if heads is equal to heads, we're going to print the coin was heads, and then we could say else print the coin was tails. Now if we run this and the user types heads, all is well and good, the coin was heads. But if the user makes a simple mistake and puts heads with a capital H, it will still say the coin was tails. So rather than doing an if else, we should really say if heads is equal to heads, the coin was heads, but elif heads equals tails, the coin was tails, and then we can do an else to say print you entered an incorrect value. So this time if I type heads with a capital H, it will say you entered an incorrect value, and then we can do the same for tails, the coin was tails, or with a capital T, you entered an incorrect value. So important to consider, if you're catching all other cases with else, you don't want heads with a capital H to equate to tails. We could fix this by doing heads, and there is a function called .lower, and this will make it, whatever the user types in will be converted into lowercase, which is what the function lower does, and then it will compare it. So if I do this and type heads, it will still say the coin was heads, and if I do it and type tails, it will say the coin was tails. If I run it and say something random like hello, it will still say you entered an incorrect value. So functions like lower are very useful, and we're going to talk about loops in the next video, but you could use a loop around this to make sure that the user does actually enter heads or tails. And if we wanted to have it so that this actually does create a Boolean, we could just make this say heads is equal to true, or heads is equal to false, and this won't actually do anything if you type something correctly, but it will create the heads value as true or false, and later on we could say if heads is equals to true, print the coin was heads, else print the coin was tails. Now, with this, if the user enters an incorrect value, because we have the heads as the input value as a string up there, this will still be the string, which cannot be true. But if they enter the correct value, it will overwrite this variable heads, the string, it will overwrite it with the boolean. So if I do this and say heads, it will still say the coin is heads. So this happens, heads is replaced as a string to true, and then if heads is true, the coin was heads. I can do the same with tails. The coin was tails, so it replaces heads with false, and if it's not true, it's going to be false. The coin was tails. However, if I do something incorrect, like hello, it will say you entered an incorrect value, and it will still say the coin is tails, because heads is not equals to true. So again, we could do elif heads equals false, and we could just leave it so there's no else. So if they enter an incorrect value, nothing happens. It will just say you entered an incorrect value. But if they do type something correctly, like heads, it will say the coin is heads still. So this is the preferred way. If you're asking the user for Boolean values, it's better to use some kind of if statement like this. And if you really need them to have entered something correctly, rather than just saying you entered an incorrect value, you could put this inside a loop that runs until they do put something incorrectly, and then you could do something with those Boolean values later. And it doesn't just have to be printing things out. You could use it to do another coin flip, or if they get 3 heads in a row, give them some kind of bonus, something like that. So hopefully this has been a useful introduction to if, elif and else blocks in Python, and we've looked at the 4 main Boolean operators: is equals to, we had not equal to, less than, and greater than. Thank you for listening. Goodbye.